We will be having a note check next week sometime. So you'll get your notes graded. I don't know, whenever I lay down the edict.
Give me your notes.
So make sure that you have your notes with you, so that you can get them graded whenever I'm like, time for notes. All right. We also have another test next week on Wednesday. So be prepared for that. And then on Friday, the 13th, is the last day to turn in any CPs. Any class practices that you were sick for or forgot to turn in or whatever. If you have those and you want to turn them in, then you need to do that by Friday. Okay, so we are solving rational fractional equations, and it involves basically everything we've done for this whole semester. So it's kind of phenomenal. And I want to refresh our brains on how to solve this, which is a quadratic equation. How do I know that it's a quadratic equation? It's an x squared, the power. If it has an x squared, then it's what we call a quadratic equation, and we solve it by setting it equal to 0 and then double bubbling. Okay, so I am going to move these couple of terms over to the left-hand side. So I'm going to subtract the x and I'm going to subtract the 2 so that they move to the left-hand side. So I have x squared, 2x minus 1x is 1x, and then minus the 2, and it's set equal to 0. All quadratic equations you solve by setting equal to 0. Then we can double bubble. If double bubbling didn't work, you would use the quadratic formula, but that's not the goal today, so everything should factor if you have a quadratic. X times x is x squared. What times what is negative 2? Positive 2 and negative 1. Again, check the rainbow if you need to. And then how do you solve for x? Set the bubble equal to 0. So x plus 2 gets set equal to 0. X minus 1 gets set equal to 0. And then we can isolate x. So I'm going to subtract 2. So we get x equals negative 2. And here I would add 1. So we get x equals 1. So some of our equations today will be quadratic, and you'll need to set them equal to 0 and factor and solve. Some of our equations will be linear, where you just need to isolate the variable, or get the letters on the left and the numbers on the right and isolate. But they are rational fractional equations. And so what I like to do is bring back some logic for the equal sign. If x over 7 equals 5 over 7, what's x? What's x? 5. Yeah? Okay, good. If x plus 2 over 7 equals 5 over 7, what's x? 3. It's pretty easy to solve that, right? Logically, if the denominators are already equal, logically we get to ignore them. They don't play a role when they are already equal. And then it's easy to see that just x equals 5, right? And same thing down here. Logically, if these are already equal, I get to ignore them and figure out what makes the rest of it equal. All right? So today we have rational equations, and what we want to do is use logic. We want to make those denominators all be the same thing. And if they're all the same thing, I get to ignore them. And that's a great way to solve these equations. Make a match and then just ignore them altogether. Okay? So that's what we're going to do. Example 1, what is x not allowed to be? Always the very first thing we should think about when we have rational fractional equations. Then we're going to solve the equation and check our answers. Can always check by plugging back in. Checking for balance, the left and balance on the right. What is x not allowed to be? Solve and check. All right, we have 4 over x. You? No, your sister. Okay. I was wondering. I was like, the right thing. Okay. All right. So first of all, before we begin, what is x not allowed to be when we look at this first equation? What is x not allowed to equal? If you plug a number in, 0. Good. So if we take a number and we plug in a 0, we would have 11 divided by 0. And my calculator doesn't like that. We get a divide by 0 error. Okay? And so we cannot have x cannot equal 0. Once we know that, now our job is to make all of our denominators the same. So I have a factor of x here. A couple of them have an x. This one has a 2 in the denominator. I need them to all have the same parts. What does this first fraction need? A 2. It needs a 2 on top and bottom. The second fraction has a 2. What does it need? An x. It needs an x on top and bottom. The last fraction has an x. What does it need? A 2 on top and bottom. And now I can rewrite my fractions as 4 times 2 is 8 over 2x plus 5x over 2x equals, what do we get for this fraction? Negative 22 over 2x. I like how you put the negative on top. You want to do that. Do all the denominators match? Yes, they do. And since all of the denominators match, I get to ignore the denominators and just solve the leftover equation. 8 plus 5x equals negative 22. Is this a linear or quadratic equation? It's linear. It is linear. Linear means it's got an x to the first power. It's just a plain old x. And linear equations, you want letters on the left is one way to solve it. Letters on the left. There's my letter. 5x is on the left. I want to move the 8 away. So I'm going to subtract 8. So I get 5x equals, what's negative 22 and a negative 8? Negative 30. How do you isolate x? Divide by 5. So for linear equations, one way to do that is letters on the left. So we get x equals negative 6, which is a good thing. It's not 0. That's okay. This number should work. If I wanted to check this, I could plug it back into my original equation. I would do 4 divided by my negative 6 plus 5 divided by 2, and that left-hand side has a decimal value of 1.833. I'm going to compare it to the right-hand side. Negative 11 divided by the x value, which was negative 6, also has that same value. So the left and the right side have balance. Okay, so we can check that way if you wanted to, but most of the time it should work just fine. All right, I'll take Carol. There you go. All right. Letter B. I want everything to be a fraction. What should I do to change the 7? Put a 1 under it. Yes. Make things turn into fractions so that we can compare the denominators. Now, x minus 2. What is x not allowed to be? X cannot equal 2. Why? Because 2 minus 2 would be 0, and that's not allowed. Okay, so right off the bat, I know x is not allowed to be 2. Now I just need to make all my denominators match. This has a denominator of x minus 2. That's a great factor. This only has a 1. What should I do to make it match? Multiply by x minus 2 on top and bottom. So we're going to multiply by x minus 2 on top and bottom. This fraction already has the x minus 2, so I don't need to do anything. That gives me 5x over x minus 2 equals what over x minus 2? What does this numerator become? 7x minus 14. Good. Plus 10 over x minus 2. Do all of my denominators match? Yes, they do. So what do we get to do? Ignore them. And we have 5x equals 7x minus 14 plus 10. Is this linear or quadratic? Linear. Linear, letters on the left. So I'm going to go ahead and move this 7x to the other side. Letters on the left. 5x minus 7x is negative 2x. And on the right here, negative 14 and positive 10 gives me a negative 4. How do you solve for x? Divide by negative 2, divide by negative 2. So x equals 2. Huh. Why are you humping? It's not supposed to be 2 right off the bat. Yes, this is because we already knew x was not allowed to be 2 from the beginning. This is what we call a false solution. So we would write no solution. It's not allowed to be 2. So what happens when it's 2? If I were to try it, if I were to plug it in and check. So I would do 5 times the 2 on top, and on my denominator, I'd have 2 minus 2. What's going to happen with 2 minus 2? Undefined. Cannot divide by 0. Doesn't work. It's a false solution. All right. That's why we check what x is allowed to be or not. 2 more. Letter C. X minus 2 over x minus 2 equals 6 over x squared minus 4 plus 1. I want to look at all my denominators first because the same rule still applies. Factor first if you can. It's terrible. Is there something we can factor? Yeah, x squared minus 4 is factorable. That same rule, which has been the phrase of the week, factor first if you can. I can rewrite that. How does x squared minus 4 factor? X times x is x squared. What times what is negative 4? Positive 2, negative 2. So if you see something that you can factor, you definitely want to factor that first. And I want everything to be a fraction. Now, before I do anything else, what is x not allowed to be? What is x not allowed to be? If I plug in a -2, -2 plus 2 would give me a 0, so x cannot equal -2. And here, if I plug in a 2, 2 minus 2 would give me a 0. So x is not allowed to be 2, and it's not allowed to be -2. Same thing as here, 2 minus 2 would give me a 0. All right, now I want to make all my denominators match. 6 has a couple of bubbles. I want to make sure I've got all of them. So this first fraction already has the x minus 2. What's missing? X plus 2. Yes, so I need x plus 2 on top and bottom. My fraction with the 6 is good. It's got both bubbles. What does the 1 need? It needs both of them. It needs an x plus 2 and an x minus 2 on top and bottom. I didn't have to do anything to the 6, so that fraction is fine. What do I have to do with my numerator on the left here? Distribute. Yes, I need to FOIL those bubbles together. So be very careful. X times 3x is 3x squared. Then I have x times -2, which is -2x. Distributing the 2, 2 times 3x is 6x, and 2 times -2 is -4. So watch when you're multiplying bubbles together that you distribute properly. This third fraction with the 1, again, it has my denominator that I need. And again, I need to multiply the numerator together. What is x plus 2 times x minus 2? X squared? Is that it, or is there more? -4, yeah. -2x and +2x cancel out, and then 2 times -2 is -4. Do all the denominators match? Which means I get to ignore them. Yay. Now I'm left with 3x squared. I'm going to combine my like terms. -2x and +6x is 4x minus 4 equals 6 plus x squared minus 4. So I can combine the 6 and the -4 just to be a +2. Six minus 4 gives you +2. Is this a linear or quadratic equation? Quadratic. Quadratic because of the x squareds in there, which means we want it to be equal to 0. So I'm going to move everything over to one side. So I'm going to subtract x squared, and I'm going to subtract 2 to move them away. So I get a 0 on one side. 3x squared minus 1x squared is 2x squared, plus the 4x minus 6 is equal to 0. Then what can we do? We would want double bubble, but is there something in common we see here? 2. Lots of 2's here. I'm going to take out the 2 because that'll make it easier for me to factor. If I take out a 2, what's left behind? X squared plus 2x, and then minus 3. Very good. And now we can double bubble those leftovers. What x times x is x squared. What times what is -3? -1 and positive 3. Very good. And then we set each bubble equal to 0. I could try to set the 2 equal to 0, but does 2 equal 0? No, so we can't do that. That doesn't make any sense. And here we have x minus 1 equals 0, which means x equals 1. And x plus 3 equals 0, which means x equals negative 3. Those answers should work just fine. They don't conflict with what we said x was not allowed to be. So they should both work. All right, letter D. 3x over x plus 1 equals 12 over x squared minus 1 plus 2. Factor first, still applies. What can we factor? X squared minus 1, factors. Double bubble, x times x is x squared. Positive 1 times negative 1 gives me the 1. Now, I can see what x is not allowed to be. What is x not allowed to be? Negative 1 and positive 1. Again, if I plug those in, negative 1 plus 1 would give me a 0 for that bubble. And 1 minus 1 would give me a 0 as well. All right, now we need to make our denominators match. So I have a denominator here with a 1. I already have an x plus 1. What does it need? X minus 1. Very good, on top and bottom. So x minus 1 on top and bottom. This has both factors already. What does the 2 need? It needs both of them. X minus 1, x plus 1 on top and bottom. All right. I have both of my bubbles. What's my numerator? 3x squared minus 3x. Very good. Got to distribute that 3x there. Equals, we have 12 over x plus 1, x minus 1. And then, this is a tricky one. My denominator is good. What do I have to do with this x minus 1, x plus 1? I need to FOIL those bubbles together first. And there's still a 2 out in front. X minus 1 times x plus 1 is, x times x is x squared. The outside and the inside cancel out. And negative 1 times positive 1 is negative 1. It's all still being multiplied by 2. My denominators match, so I get to cross those off and just look at what's left over here in the numerators. What do I have to do with this 2? Distribute it, yes. 2 times x squared is 2x squared, and 2 times negative 1 is negative 2. There's a big plus sign in there. Is this linear or quadratic? Quadratic, which means I want to set it equal to 0. So I'm going to move all this stuff over. I'm going to subtract the 2x squared. And I'm going to subtract the 12 and add the 2. So that everything is gone on the right side in this case. 3x squared minus 2x squared is 1x squared. Then I have my negative 3x. My negative 12 and positive 2 is negative 10. Then I can double bubble. X times x is x squared. What times what is negative 10? Negative 5 and positive 2. Very good. Which means x equals positive 5 and x equals negative 2, which doesn't conflict with these values, so we're good. So we're just fine. Do you have questions for me? All right.